Imagine a bridge so massive that it looks like it disappears into the horizon. It stretches for miles across open water, carrying thousands of vehicles every day. From a distance, it may look like nothing more than a road suspended above the ocean. But building something this enormous is one of the most difficult challenges in modern engineering. So how do engineers actually build bridges that stretch across massive bodies of water? It all starts beneath the surface. Before construction begins, engineers have to understand exactly what lies underneath the water. They use sonar, drilling equipment, underwater surveys, and specialized ships to map the seabed and locate layers of strong rock that can support the enormous weight of the bridge. Because if the foundation fails, everything above it fails with it. Once the location is carefully selected, engineers begin installing massive foundation piles. These steel or concrete piles are driven deep into the seabed, sometimes dozens of meters below the surface. Think of them as the roots of a giant tree. They transfer the weight of the bridge deep into the ground, allowing the structure above to remain stable even when powerful waves and currents are constantly pushing against it. But building underwater is a completely different challenge. Workers can't simply stand on the seabed and start building. Instead, massive construction barges, drilling platforms, cranes, and specialized equipment are brought to the site. Some of these machines are so large that they look like floating factories. Once the underwater foundations are secure, enormous concrete structures are built on top of them. These foundations will eventually support the bridge's towers. And this is where the scale of the project really becomes visible. For a massive suspension bridge, towers can rise hundreds of meters above the water. Building them requires thousands of tons of steel and concrete, carefully lifted and positioned at incredible heights. But the towers are only part of the system. The real magic happens with the cables. The main cables stretch between the towers, forming the backbone of the bridge. Then, hundreds or even thousands of smaller cables connect those main cables to the roadway below. Together, they create a system that distributes the weight of the road, vehicles, and everything else across the entire structure. But there's another problem. The bridge has to be incredibly strong without being completely rigid. Because a bridge this large is always moving. It expands when the temperature rises. It contracts when the temperature drops. Strong winds can make the structure sway. Heavy traffic can cause the roadway to flex. And in some parts of the world, engineers even have to design for earthquakes and powerful storms. That's why modern bridges are built with carefully engineered expansion joints, flexible connections, aerodynamic shapes, and systems that allow controlled movement. Then comes one of the most difficult stages of all, building the roadway. Huge sections of steel are manufactured separately and transported to the construction site. Some are lifted into position by massive cranes. Others are assembled on specialized platforms before being moved into place. Piece by piece, the roadway begins to stretch across the water. Every section has to line up with extraordinary precision. A tiny error at one point can become a much bigger problem when hundreds of sections eventually have to connect. And throughout the entire process, engineers constantly inspect the structure, monitor measurements, and test every critical component. After years of construction, the final sections are finally installed. The towers are connected. The cables are under tension. The roadway is complete. And what started as thousands of individual pieces has become one enormous structure connecting two distant points across the water. From the ground, it may look simple, but hidden beneath the roadway is an incredible system of foundations, steel, cables, concrete, joints, and engineering calculations designed to survive for decades. These bridges aren't just roads. They are massive machines built to withstand nature while carrying entire cities across the water. And the next time you see one stretching across the horizon, remember this. What looks like a simple road may actually be one of the most complicated structures humans have ever built.